this is the last example for this section. Example 4, we're going to compute probabilities of a sample proportion. All right, so anytime you see compute probabilities, that means that you're going to be using your Z table, which means that you'll need to use your Z formula, but it's going to look a little bit different, but it is in fact the same formula, so I don't want it to bother you. This is Devon's formula. But in this case, it's going to be, instead of X, we're going to use P hat minus the mean of P hat over the standard deviation of P hat. All right, but it's essentially the same formula. Once you get a Z-score, you go to the Z-table, find your probabilities. All right, so in this case, according to the National Center for Health Studies, 15% of all Americans have hearing trouble. In a random sample of 120 Americans, what is the probability? At most, 12% have hearing trouble. So first thing, I need to make sure that I can apply normality to this. So obviously, 120 Americans is less than 5% of the total population. So that part's good, but I just have to check whether or not N times P times 1 minus P is greater than or equal to 10. So I'm just going to plug it straight into my calculator. So my N value is 120 times P of 1.5 times 1 minus P of 0.85, and I get 15.3. So I can apply normality to this situation, so that's good. So let's go ahead and calculate what our mean of P hat, remember your mean of P hat is P, so my mean is 0.15. My standard deviation remember, your standard deviation is the square root of P times Q divided by N. So 0.15 times 0.85 divided by 120. And I get my standard deviation of P hat came out to be 0.0326. All right, so now I'm going to use my Z formula. And they gave me, in a random sample of 120 Americans, what is the probability that at most 12% have hearing trouble? So that is the P hat that they're giving me, 12%. At most means I'm actually looking for 12% is the highest number and everything is less than that. So it is shaded left. So I'm going to plug into my Z-score formula, 0.12 minus 0.15 divided by 0.0326 to get a Z-score. My Z-score comes out to be negative 0.92. Now you could use your Z table and look it up on a Z table if you've got one handy. I'm going to just use my calculator and do a normal CDF. Because this is shaded left, I'm going to leave the top just like it is and type in negative 0.92. And I get 0.179. All right, so that would be the probability that P hat is less than or equal to 12% is 0.179. All right, that's A. Now for B, Suppose that a random sample of 120 Americans who regularly listen to music using headphones results in 26 of them having hearing trouble. What might you conclude? All right, so in this case, because we're using our 120, this is my probability. I would do 26 divided by 120. That's going to give me the percentage of people in my sample that actually have hearing trouble. So 26 divided by 120, 0.2167. That's my p-hat. So I'm going to plug that in to my z-score formula. And use my calculator. $2.046. And you could use your Z table if you would like, or again, I'll just use my calculator since it's a little easier to show on here than pulling up a Z table. CDF. I am right now going to shade from the left. That may not be my final statement, but I am going to just do a normal cumulative CDF. Okay, so remember that the data that we're looking at, what it's talking about is the samples that I've taken. So basically what this is saying is that about 98% of the time, when I take this particular sample, 120 people, 98% of the time it is going to be less than that value. Or if you want to look at it the other way, which is why I said I might not actually read it from the left, I could also say that only 2% or 2 out of 100 are going to be more, are going to have more hearing trouble than that. But that's of the samples that I take. So that's the interpretation.